So, guys, welcome back. Our next area of discussion will be on finding the first derivative from first principles of a rational function. So, like we did with previous functions, remember we did with straight line, and we said we must be left with h or h with a constant, and then we have to divide to cancel that h with the one from the formula. And then rational function, quadratic function, we said we must factorize by h, and then that h will cancel the one that is in the formula. So now the new one is a rational function. So now we want to know what will happen with rational function, since we have information on other functions. So now with a rational function, I will write in brackets combine fractions uh, as the first point, and then change division to multiplication. And remembering that if you have a over b divided by c, this is the same thing as a over b multiplied by, look at this c, it's over c over 1. And then if you change into multiplication, remember you have to take the inverse, change the fraction, and then that means the numerator will become the denominator and the denominator will come the numerator. So you need to take note of this. You change fraction to division to multiplication, and then you must know how to combine fraction. And then the last part, the h will cancel the one in the formula. So now let's go through it so that you'll see what will happen with this one. You'll see that we'll get all these parts as we are trying to find the first derivative. So now I'll write the formula, because it's important that you start with the formula so that you can see what is it that you have to find. And grade 12s, you don't have to memorize the formula. It's there in the information sheet. You just have to be familiar with it. So now, like with the previous functions, the first thing that we are finding was f of x plus h. So now, what is f of x plus h? This means that where we see x, what are we going to put? So here is our x. It has changed. Now it is x plus h. So that means here, where we see x, we will put x plus h. So we will have negative 2 over x plus h. So now this is your first step. You see there's nothing that we can do here. And please, grade 12s, don't separate it like this, and then you'll say you have negative 2 over h. This is wrong. Don't do that. So with the rational function, after substituting your x plus h, you are done. So now number 2, like with the previous ones. So in step number 2, we're finding f of x plus h minus f of x. So now, what is f of x plus h minus f of x? We just take what we found in step 1, which is f of x plus h. So we have negative 2 over x plus h minus, don't forget the bracket. Remember, after this minus here, you need the bracket so that you can deal with the signs. So we'll put the bracket here. So now what is your f of x? So now your f of x, if you check, is given there is negative 2 over x. So now here, if you check, we have negative 2 over x plus h. Remember, we have to get rid of the bracket. So we have negative 1 there. So negative 1 multiplied by negative 2 over x. That will give us positive 2 over x. So now, this is where the nice things start. Remember what I said. You must know how to combine fractions. So now we'll take you through example with numbers. So let's suppose you have 1 over 2 plus 4 over 3. So now to combine these two fractions, you multiply the denominator. So the denominator is 2 and 3. So we have 2 multiplied by 3. So we have 2 multiplied by 3. And then the second part, 2 multiplied by 3, you divide it by the first denominator. So the first denominator is 2. So 2 multiplied by 3 divided by 2. So what will happen to the 2? So this is what we have, 2 multiplied by 3 divided by 2. So 2 is the first denominator. So the answer will be 3. So now this answer, which is 3, we multiply it by numerator. So 3 multiplied by 1, that's 3, plus. We just drop that plus there. So now we take the same thing again. So we have 2 multiplied by 3 divided by the second denominator, which is 3. So the answer there will be 2 because the 3 will cancel. So now these 2 we multiplied by numerator. So 2 multiplied by 4, that's 8. So the answer will be 8 plus 3, that's 11. Then 3 times 2, that's 6. So that's your answer. So I was just taking you through what we have learned previously with respect to combination of fractions. So we're going to use the same idea here. So when you want to combine fractions, I said you multiply the denominator. So our first denominator is x plus h. So we have x plus h, and then we multiplied by the second denominator, which is x. So now remember, to proceed, you take the same denominator that you have, so which is x plus h times by x. We divide it by denominator of the first term. So what is the denominator of the first term? It's x plus h. So we divide it by x plus h. So now you can see what will happen with x plus h and x plus h. They will cancel, and then we'll be left with x. So now what do you do with that x? You multiply it by numerator. So what is negative 2 times x? You have negative 2x. And then the sign, you drop it. So we have plus. So now we have we do the same procedure. We take the new numerator, which is x plus h multiplied by x, divided by the second denominator, which in this case is x. So the x will cancel, and then you'll be left with x plus h. Nice. So now this x plus h, what do you do with it? You multiply it by the numerator. So we have 2 times by, put it in brackets, it will times by x plus h. So that's how you combine fraction, or if you have a different approach, you can combine using the different approach. So we have negative 2x. So we have positive 2 times x. So that's positive 2x. Then positive 2 times h. That's positive 2h all over. So here in the denominator, you can either simplify it or leave it as it is, no problem. This answer will be the same. So I prefer leaving it like that. So we have x plus h times x. Tell me, what do you see in your numerator? Cancelling. Can you see the cancelling there? So we're left with 2h over x plus h and x. So this is what we have. So now, remember, after you are done with step 2, now you consider your formula. So I want to show you the nice part here, or the part that you need to take into account. We know this part. We find it in the step 2. So what is our step 2? The final answer, the one with the tick. This is our step 2. So the formula is, let me write the formula. It will be better if I write the formula. So remember, you don't forget the limit as h goes to 0. So now, this part here is equal to this one. So that part is 2h over, I'm trying to see if I did not make a mistake. Okay, no problem, no mistake. So this part here is this part here. So we have 2h over x plus h times x. And then remember this h here. Instead of writing it as a denominator, we're not going to do that. We're going to use the this division. So we say divided by h. So now I want you to check what will happen. So we have limit as h goes to 0 of 2h over x plus h and x. So now, what did I say about this one? You need to remember I said this x, remember I said in the steps, I said we need to change division to multiplication. That's what we did here. We changed, okay, that we have to do it. So now remember that h over 1, and then if you change division to multiplication, you will have 1 over h. So that's what we have now. And then if you go back, what I said is after you changed, the h will cancel the one in the formula. So now if we check, this is the h that is in the formula. And can you see that h that we got from step 2? So this h will cancel that one in the formula. So we'll be left with, so let me, okay. So we have limit, we have f prime of x equal limit as h goes to 0. Let me write that part. We had 2h over x plus h into x multiplied by 1 over h. So we're on this part. So what I said is this h is the one from the formula. It will cancel that one we got from step 2. So now what will be left with? We'll be left with limit as h approaches 0, then 2 times 1, that's 2 over x plus h, and then x. So now remember, the last part is to substitute the value of h. And when you substitute the value of h, you don't have to write the limit again. So now what we'll have is the limit as h approaches 0. Oh, sorry, I'm substituting the h, so I don't have to put the limit. So we have 2 over x plus 0 into x. So now if you notice, x plus 0 is x. So we have x and then the second x. So the answer will be 2 over x squared. So now this is your answer for your first. So this is your answer for your first derivative. So we did linear, we did quadratic, and we did rational function like hyperbola. So the last one will be okay. So the last ones will be the radical functions, the one with surds, the square roots. So we have y. Okay, let me use f of x equal the square root of x. So now, like with the previous ones, so for this one, what I will write, or the key will be to rationalize. You need to know how to rationalize. So I will take you through an example of rationalizing. So suppose we have square root of 2 over the square root of 2 plus the square root of 3. So now, how will you rationalize this? So to rationalize is to change a form or to write expression or fraction in a different way, in a different manner. So what we'll do is we will look at our denominator, and then after looking at our denominator, what we will do is we will multiply the whole fraction with the denominator, but with change in the middle sign, the sign that will separate the two terms. So now, what is the sign that separates these two terms? It's plus. So now If we rationalize, we will multiply the fraction with the same thing but with a different sign. So we have square root of 2 minus the square root of 3. So now if you look at this part here, so if you look at this part here, that's the same as multiplying by 1. So that is how you rationalize. So I'm not going to solve it. I'm just going to show you how do you rationalize. So now I want us to look at the second one. I want us to look at this radical function and see how we can find its first principle, its derivative from first principles. So we will use the same procedure. You write the formula: f prime of x equal limit as h goes to 0 of f of x plus h minus f of x all over h. So now remember, the first step is to find f of x plus h. So now with f of x plus h, it means where we see x, we will put x plus h, and then here is your x inside the bracket, inside the square root there, which is called a radical. So our x, we have the square root, and then what is your x? It's x plus h. So we have square root of x plus h. So now you are done. Don't change it to x plus h to the power of 1 over 2. We know it's the same thing, but don't change it. Leave it as it is because we are going to rationalize. So we will need that square root. So now part number two is to find f of x plus h minus f of x. So now what is your f of x plus h? Your f of x plus h, you have it in the step 1, in the first step. So that is square root of x plus h minus, now what is your f of x? Remember, your f of x is always given, so that is the square root of x. You see it's a one term, so I can just write it without brackets. Remember, you put brackets if you have more than one terms. So if you have more than one terms, you will just put the brackets so that you can multiply with the negative using distributive property. So now you see here, there's nothing more that you can do. Don't change the square roots to exponent of 1 over 2. We need them so that we can rationalize. So there's nothing more with finding first derivative of radical functions. So we'll just go ahead and make substitutions. So I think from straight line function to radical function, now we know the procedure. We know this part here, which is our numerator. We have it in step 2. So we'll have square root of x plus h minus square root of x all over h. So now what we will do is we will rationalize. So now how do you rationalize? Means you multiply by, you look for your square roots, that sign that is separating them, and then you change that sign. So this is square root of x plus h plus square root of x all over square root of x plus h plus square root of x. So now this is what you have. So we have limit as h goes to 0. Notice that if you look at these two brackets, when you multiply them, you'll get something like difference of 2 squares or something like that. So there's no need to be multiplying, to be using FOIL. You can just multiply the first terms and the middle sign will be minus, and then you're done. So first term, this one multiplied by that one, that will be x plus h, and then you multiply the last ones, square root of x multiplied by square root of x, that will be minus x. If you want to FOIL it, you'll see that you'll get the same answer, but I view it as difference of 2 squares. So now what do we have here? We have h into the square root of x plus h plus the square root of x. So this is what you have. Please tell me you see what will happen in our numerator. The x and the x gone. So we have h over h into the square root of x plus h plus square root of x. So tell me what's going to happen to the h. So h will cancel h. So now we will have the limit as h goes to 0 of 1 over the square root of x plus h plus the square root of x. So now you can substitute the value of h for x and tell me what do you get as your answer. So you can just write the answer in the comment section.